Good day and welcome to the IEEE Computer Society's presentation on Try FSharp for Big and Broad Data by Evelyn Villegas, Christopher Poulan, Don Syme, and Kenji Takeda. This webinar is proudly sponsored by Microsoft Research. My name is Chris Ruoff. I'm a Senior Manager with the IEEE Computer Society, and I'll be moderating the presentation today. Before we get started, I'd like to mention a few housekeeping items. At the bottom of the presentation window, there is a button that will allow you to enlarge the slides. You can control the volume for this webinar by using the media player on the left side of the presentation window. Use the icon shaped like a speaker to adjust the volume. And you may also have to adjust the master volume on your computer. At the end of the presentation, we'll have time for some questions, and we hope that you have several. So as questions occur to you, please type them in the box provided on the lower left portion of the presentation screen and then press the submit button. You don't need to wait until the end of the presentation to begin submitting questions, so please send them in as you think of them. Now I would like to introduce our four speakers for today's webinar. Evelyn Villegas is the Director of Semantic Computing at Microsoft Research. Semantic computing is about interacting with data in rich, safe, and semantically meaning ways to create the path from data to information, knowledge, and intelligence. Her latest project working in partnership with universities and developers includes Try FSharp. Christophe Poulan is a Senior Research SDE in the Connections team of Microsoft Research. One of his current interests is the development and the application of software to solve problems that involve massive amounts of data and computation. His recent project includes functional programming in the browser with Try FSharp. Don Syme is a principal researcher at Microsoft Research in Cambridge. His main current responsibility is the design and implementation of FSharp, though he's also worked on C# and indirectly Visual Basic and other .NET languages. His area is programming language design and implementation, with emphasis on making functional languages that are simpler to use, interoperate well with other languages, and which incorporate aspects of object-oriented, asynchronous, and parallel programming. And finally, Dr. Kenji Takeda is a solutions architect and technical manager for the Microsoft Research Connections EMEA team. He has extensive experience in cloud computing, high performance and high productivity computing, data-intensive science, scientific workflows, scholarly communication, and engineering and educational outreach. Now I'd like to turn it over to Evelyn to start the presentation today.
Thank you, Chris. Welcome, everyone. Welcome to this webinar on Try FSharp. So what is Try FSharp first? This is an easy on-ramp to learn in FSharp. FSharp, which is an open source, practical, functional language that lets you write simple code to solve complex problems. So first of all, so what are we going to do here? We're going to focus on the latest features of FSharp 3.0. And what Try FSharp allows us to do here is to learn about those features. It also enables us to create code and share it with others while doing all that in your browser. So let me tell you now who is going to do what. So Kenji in a second is going to take over to go over the basics of FSharp, Try FSharp, and talk about the importance of a new paradigm for programming languages, which is the information-rich paradigm. Then we'll have live demos, which will be done by Christophe. And finally, Don, who is the FSharp architect, will bring us back to how to program at internet scale and also where we can meet the community. So now let me just summarize our agenda today. Here it is. So it's about introducing FSharp in the browser, so it's cross-platform with tryfsharp.org. And then we're going to focus the rest of the hour on the information-rich programming as part of the live demos. Kenji, take it away.
Thank you, Evelyn. So FSharp is an open source language derivative of OCaml, and it's been in development. It started in Microsoft Research, and it's now actually transitioned out into the open source community. There's a software foundation at fsharp.org, and it's really an interesting language that allows you to, solve really complex problems with really simple code using a functional first paradigm, but it is also allows you to write OO code, and you can interop with, for instance, C# libraries. So it runs on the .NET platform. Various IDEs, including, of course, Visual Studio, including the free versions of Visual Studio. So it's a fantastic way of being super productive and being able to kind of think more clearly by using a functional first sort of way of programming. And so what we tried to do with FSharp was to make it really easy for people to get going and literally try FSharp from a web browser. A couple of years ago, we did the first version of FSharp, which supported, for instance, units of measure, a unique feature of FSharp. And then we just this year refreshed the site to support the latest version 3 of FSharp, which has a really interesting and fantastic new mechanism called Type Providers. So if you go to tryfsharp.org, you can find tutorials to get started with FSharp and do much deeper dives into FSharp, including data science, financial computing, where FSharp is getting a lot of traction in financial services and insurance, where they have to write very complex code, and it allows them to think very clearly and, for instance, write mathematical code. So one of the new things in FSharp 3.0 is this ability to integrate information into the language. And that's really come of age, because if we think about the world we live in, where we have lots of devices like smartphones and tablets, and we have lots of services up in the cloud, we really live in the middle of an information society. We've gone through farming and agriculture, through industrialization and building things, and now we really think about our lives as being bathing in information. And what that means is that we need our applications, our devices, and our services to be able to integrate with this information. So what we really need are programming languages that support that type of paradigm. And so what we really need is scalable data programmability. And when we mean scalable, we don't just mean with a database, with your own app, enterprise app, but we mean at true internet scale. So if we look, for instance, at ProgrammableWeb, we can see the number of web APIs, and it's really a sort of exponential growth in terms of the number of APIs that are being made available over the web. I mean, thousands of APIs, every pretty much cloud service, company service that's up there is exposing those services as APIs. And what that means, however, is that when we're programming against these APIs, we need to have a really good experience. And if we think about how computer languages have evolved over the last decade or two, it's really not been in this world of bathing in information. So what we have now is the experience of if I'm programming in my favorite language in my IDE, and I want to be able to program against an internet information source. Okay, so a web service essentially that's providing data. So that could be Wikidata, it could be FreeBase, it could be the Azure Marketplace. To do that, and to do that through, for instance, different APIs, there's a lot of friction if we're used to things like IntelliSense and having, methods at our fingertips and objects at our fingertips. It's really, really difficult, real sort of high friction. And so what we need is a really, really simple programming model that allows us to access these different information sources in a very, very nice way. So a new thinking is required for our programming language design that scales at internet scale, we mean the whole of the web and all of those APIs, social network APIs, retail APIs, search APIs, all of those Web 2.0 and now Web 3.0 APIs. In order to do that, it really has to be on demand. We can't pre-compute code gen into a DLL, for instance, that information space. And we want a plug-in model because we don't know what information source or what format's coming out tomorrow. So in order to do this, the FSharp team and Don Simon in the Microsoft Research Cambridge Lab have developed an adapter technology called Type Providers, which allow us to bridge from the programming language, in this case FSharp, into an information space. And what that means is that if I go out to a web, a web service that has some data, I can essentially attach to that data source with a type provider. And what it does is it pulls back the metadata schema from that information source and literally pulls it into the language so it's available at my fingertips in the same way that sort of objects and classes are available, for instance, in IntelliSense. And so Type Provider is a unique new mechanism that allows us to bridge from the programming language, from the IDE, and Christoph's going to show you what that looks like right now, into any of these different information spaces. And it's a really exciting, brave new world, really, in programming languages at internet scale. So I'm going to just hand over to Christoph now, who's going to show you ThreeBase and then show you what that looks like and the power of type providers and how it can really make programming against the web really exciting. So over to you, Christoph.
Okay, thank you, Kenji. Let me now share my screen. It's going to take a few seconds. And so what I'd like to do in this next section is show you the ThreeBase site and show you how you can use it to learn about FSharp, and then dive into the data aspect of the language and show you concrete examples of type provider so that you leave today with a good idea of what it means to bring data at the fingertips of the programmer. So I hope everybody can see my screen right now. I have my web browser open, and we're looking at the tryfsharp.org website. So as Kenji mentioned, when we were trying to find a way to make FSharp approachable and easy to try for many people, we came up with the idea of a website. A website where you can not only learn about the language by taking tutorials, guided tutorials, and I'll come back and show you how those work, but also a website where you can actually play with the language. And so this is all in the browser. And when we go to the Create tab, we're providing an editor here where I can type some code. And at the bottom here is an output window. So if I click Run, what I've just done is I wrote a simple FSharp expression, 1 + 1, and the compiler basically compiled the code and interpreted it and ran it, and at the bottom we have the result. So this is basically a very simple way of writing code. There was no installation required of software. It's all in your browser. So the way you run code, you can either type your code and click the Run button. You can also select the code you want to run and click Run. And also there are some key combinations. Control-Enter is like Run, or Control-Shift-Enter to execute the single line of code. And so as I go through the presentation, I'll be using the keyboard shortcuts, and that's why you won't see me hitting the Run button. And by the way, if you play with the site, you can always go to the help page and look at the keyboard shortcuts, and they're all documented here so that you don't actually have to memorize them right now. So what I'd like to do now is switch to a script to give you a little bit of an introduction to FSharp for those of you who may not be familiar with the language. One thing with FSharp is that it's a programming language where you can write your code and compile it in the traditional way and then deploy your code into your professional application. But you can also play with F-Sharp interactively, and that's what we'll be doing in the browser. So for example, to define a list of integers that goes from 0 to 10, I can use this syntax. And then if I use the key combination Control-Shift-Enter, I can just evaluate that list. And at the bottom here, we see that we've just created a list of integers. So we have an interactive session going where I have variables and value being created and computed. Of course, F-Sharp is a functional first language, which means that functions are very important and first-class citizens. So if I want to define a function that adds two numbers, this is the way of doing it. Let's add of x of y, which is the sum of x of y. So this is very simple, and at the bottom we see that we have a new function add, which takes two integers and produces an integer. So if I want to define another function increment, we can see that I can very easily use my other function. So this is a very concise syntax where we make use of functions. One important thing about F-Sharp and that differentiates it from languages, for example, like Python, is that the language is type checking your code for you. So for example, if I have the function increment, which expects an integer, and so if we put the cursor here, we see that we get a tooltip that tells us that inc is a function that takes an integer and returns an integer. And if I try to feed that function a string, I do get an error as indicated by the squiggly. And I can again put the cursor here and I get information that says, yes, that function expected an int, but you are giving it a string. So this is the power of having a language that's type checking for you, because it prevents many errors that could be hard to debug in a real program. One thing that F-Sharp does for you is that it allows you to write code that's more declarative, so where you can express your intent. So a good example is to sum the integer in my list. I can use the sum function of the seek module. And this is contrasting that to what you would do in Java or C#, where you would write a for loop, and the intent of doing the sum is sort of hidden in the detail of the code. Another thing that you see in this environment in the browser is that we support IntelliSense. So if I have a seek module, I can actually browse through the list of functions. And if you look at the bottom here, we actually have information about the compare with function in this case, with rich metadata and information that you can use to really learn the language. One thing we see often in some of the demo today is a pipe operator, which is commonly used in F-Sharp. So for example, instead of invoking seek of sum and passing it an argument, I can sort of reverse the notation and say that my input is being fed into the seek.sum function. And so that's what the pipe operator does. And again, I can evaluate that, and I get the same result, of course. Another aspect of the F-Sharp environment is that you can not only run code, but you can also do some visualization. So if I run this code where I basically have a list of integers, which I map into a list of pairs where the x-axis essentially is the integer and the y value is the square, then I can feed that into a charting function which draws a list of points on an xy axis. So again, this is all in the browser, and this really gives you a way to learn the language in a fun way and a meaningful way. And as we come to the data part, we see that it's important to be able to visualize the data so that you can draw more insights out of it. Let me clear that graph and hide it again. Now, we don't have time today to go into the full F-Sharp language, but one thing you should know is that in the F-Sharp environment, even though we're executing in the browser, you have access to the full F-Sharp language. You don't have access to the full F-Sharp .NET libraries, of course, but the full syntax of the language. So, for example, you could do asynchronous computation using the async keyword. You have the ability to do queries, which is something that we'll be seeing a lot as we work with data. And also, you could use features like units of measure, where you can define units like gram, for example, or I can define another measure of the distance, meter and centimeters, and then I could define a number d, which is a distance in meter, define another number m, which is a mass in gram, and then I see that if I try to add my distance and my mass, I do get an error, and that's enforced by the compiler, and it's basically telling me that the units are not compatible, and therefore that's not allowed. So if you're dealing with programming for engineering problem or even for financial problems, that can be very useful to have that type of checking available in the language. So that sort of covers the basic introduction of FSharp. Before we move back to the data aspect of FSharp 3.0, I just wanted to show you two example scripts that then you can write in the browser and show you give you a flavor of the type of thing you can do with this environment. So this is a program that's probably about 100 lines long, and what it is doing ray tracing. So if I run it, after a few seconds, we see that the canvas will show up, and then the scene that we're currently rendering will show up. So, this was all computed in the browser and rendered using an HTML5 canvas environment. Of course, if you write a nice script like that, you may want to save it. So in FSharp, we give you the ability to save your script in the cloud. In order to do that, you have to log in. We support a to-login method, either using a live ID or a Facebook ID. And once you're logged in, like I am, you can save your script in the cloud. And this is a list of scripts that I have saved. And of course, if you create a script that's nice, there's no point in keeping it to yourself. You may want to share it with your friend or the community, which is a big aspect of FSharp. It's really to foster a community around the language. And so you could tweet a reference to your script, you could post it on Facebook, publish it to a community site called fssnip.net, or even use a link to embed in an email or on a blog and so forth. And to give you a sense of what sharing looks like, for example, this is a Twitter feed, and we have Antonio Cisternino, who is actually from Italy in Pisa, and he created a nice visualization script. So he tweeted about it, and so I can actually use a link, click on it, and that brings me back into the FSharp environment, where I'm now looking at the code shared by others. So this is a script that Antonio shared, and then I can run it and enjoy his nice visual work. So this is an example of a fun animation that you can actually program using FSharp, and in this case, a JavaScript library called Raphael, which is used to do the visualization on the HTML part of the web page here. So this is nice and fun. But let's come back to one of the problems that Kenji was alluding to earlier. It's dealing with data. And so as a first example, let's consider a website like ThreeBase. ThreeBase is basically a huge repository of entities, where an entity is either a person, a place, a thing, and there are a lot of entities stored in that repository, which is available on the web. According to that page, there are about 20 million topics and entities available. So there's a lot of useful information, but the question is, how do you make use of that? And when you're dealing with large graphs of data, the tooling that programmers have today is not always the easiest to get the task done. So let me find my script back. Here we go. So, for example, if you wanted to start working with ThreeBase information today, what you may have to do is write some REST API to get data to your program, and then you would have to deal with maybe with some JSON and parse that JSON and somehow carve the information that you are interested in. By contrast, with FSharp 3.0, we can leverage the concept of type provider. So someone wrote a FreeBase type provider, and now many people can enjoy the benefit of that labor. And in FSharp, if I want to use that type provider, all I have to do is basically reference a DLL, reference a library, and I can do that by executing that line. And then the next thing I need to do is create what we call a data context. So this is basically opening a line to the FreeBase repository on the web. So we're not looking at data that is static and has been brought onto my machine. Actually, we have a live connection to the web. So the moment I have that connection created, I can use the tooling provided by the environment and IntelliSense in that case to start browsing the data. So here I can see the categories that are exposed in FreeBase. And as I click through the category, you can notice at the bottom here that the information changes, because not only do we have the list of categories, but we also have metadata that tells us what we're looking at. And so if I'm interested, for example, in society, I can try digging in, and then I can see that there's a concept of celebrities, and I can keep digging in and so forth. And eventually I come to something that is maybe of interest to me, for example, super couples. You know, what is a super couple? Well, we can find out by looking at the metadata that tells us that a celebrity super couple is essentially two famous people married together. So that's one way of learning about the information. But then I can also, use my FSharp environment to start exploring that data in a more concrete way. So, for example, I may want to look at all the super couples for which an image is available. So we're doing a query against the super couples and only keeping the super couples for which a main image is provided that is not null. And then we're going to use the grid available in the FSharp environment to actually visualize the data. So let's run that, and we see on the right side a grid is being formed. So what's happening is that we actually did the query against the live data on the web, and now we're getting a list of super couples, examples of them. So you see that Beckham and his wife Porsche are an example of a super couple, and then we have Tom Cruise and Kate. I guess this is a little bit out of date maybe. But this is how you can start working with the data. And of course, you can use many topics in FreeBase. So if you are interested in chemistry, you may want to find out who discovered hydrogen, and again, you could write a different FSharp query and execute it, and you would find that Henry Cavendish is the discoverer of hydrogen. So again, this is the important point here is how from the programming environment I've been able to use the tooling and IntelliSense to browse the data as I write my program, and then write my program to actually derive some meaning. So this was one example. Let me show you more examples, and we're going to build to more interesting examples. So for the next example, I'd like to come back to the learn experience in FSharp. I mentioned earlier that there's a set of tutorials that you can follow. So if you don't know anything about FSharp, this may be the place where you want to start in order to get a guided tour, if you want, of the language. And the tutorial starts with the basic information about FSharp to some more advanced notion about the language, how to do data visualization in FSharp, and then there are more domain-specific that deal with data science, scientific and numerical computing. And for now, I'd like to drill into the financial computing section. So when you open one of those sections, what you are presented is essentially a list of chapters. You can think of it as a book on financial computing, and then there are different chapters. And I can open a chapter and start reading a page in that chapter. So in that case, I'd like to focus on an example of using financial data available on the web. So this is actually finance data from the Yahoo website that data is available in a tabular format. So if I have that URL, I could click on it, and then the file would open. In my case, I have Excel open, so the CSV file opens in Excel. And you can see that what we have is a comma-separated value file, where the first row is a set of headers, and each subsequent row is a row of data with things like date, the value of the stock when the stock market opened, the value at the close, high, low, and the volume, and so forth. So what if we wanted to use that data to derive some meaning? You can think of what you would have to do in order to ingest that data and start working with that data in your favorite programming environment. Again, using FSharp type providers, we can very easily ingest that data and start working with it. And so that particular tutorial is really demonstrating to you how you can use a certain type provider called the CSV Type Provider, which, as its name indicates, is there to ingest comma-separated value files. When you go through a tutorial, not only can you read on the left side, but the code sample have load and run buttons. So if I click that button, you notice that the code is automatically imported into the editor, and it's also evaluated right away. So what did we do here? Like for the ThreeBase Type Provider, we referenced the type provider, in this case the CSV Type Provider, and then we pointed that type provider to the data that we want to access on the web. So this is a website that the web page that I just accessed a few moments ago. And once that's done, basically the data is available for me to work with. So if I looked at the first row of the data, I can see that there are different properties that correspond to the columns in my comma-separated value file. So I have, for example, the date, or if I'm interested in the price at the close of the session, here it is. And I can print it, and I can see that the price is here. And of course, I have the all data available to me. Now, one thing you notice here is that we access the date, but if we look at the type of the date, it's a string. And of course, in a programming environment, we'd like to deal with the data as a data object, not as a string. Well, the CSV Type Provider allows you to do that. There are different ways in which it can import data. And the tutorials explain sort of the parameters that you can supply to the type provider. So for example, if I want to do explicit type setting, I can tell to the type provider that not only do I want to import that data, but I want the first column to be mapped to a date and the second column to be mapped to a float and so forth. And so once I do that, if I hover over the date, we see that now that the date has a strong type of system.date.time. So I can write code against that type, and the compiler can help me enforce that I'm doing operations that are valid for dates. I don't have to deal with strings. Of course, if you don't want to specify the types explicitly, there's another option in the type provider to let it infer types. And then what the provider will do is look at the data up to 5 rows in that case and try to automatically infer the type from the data, which works well in some cases, but in some cases that can be fragile. That's why we have those different options. And then now if we look at the date again, it is a date time as we would have expected. So this is the type of tutorials that you get, where we introduce not only a concept about the language, about the type provider, but eventually also we come to the actual domain, the financial computing. And so if we were to follow that tutorial, we start analyzing some stock data, and I just go to the bottom bottom example and show you that eventually we pull data from different sources and look at the stock prices over a certain period of time and start doing some analysis. And again, if you go through the entire tutorial, you see that, especially towards the end, there are much more advanced notions of financial computing which are being explained in quite some detail. Now let's move on to another example. We just saw the CSV Type Provider being applied to financial data. But what's nice about the type provider is that you can reuse them in many different contexts. So let's use that same type provider, CSV Type Provider, but apply it to completely different data. In this case, we'll be looking at earthquake data. So again, if I open this site here from the USGS, it's a very nice site where earthquake data is made available via feeds. And so, for example, we can see that we can get earthquake data for the past months for earthquakes which had a magnitude of 2.5 or more. And for example, one format available is a CSV data format. So again, tabular data that I can then use in my programming environment. So coming back to that example, then all I have to do to use that data is point the CSV type provider to my URL and ask it to infer the type. And so if I execute that line, now I can start writing code against my data. And in a matter of essentially 6 lines of code or so, I've found out that in the last 30 days there were over 1,100 earthquakes. And of course, from there I can continue with my analysis. For example, I may want to find out which were the top earthquakes in those 1,118 earthquakes. And to do that, I can do a query against the data available on the web. I can sort the earthquake by magnitude and select the top 5. And so if I run that query and pipe that into the ThreeBase grid, then we get a table of the earthquake with their magnitudes and where they happen in terms of latitude, longitude, and a depth in kilometers. Now, so this is one way you may want to start your analysis, but clearly you may also want to visualize the data. So to do that, we could bring a map, for example, a Bing map. So now I have a map of the Earth, and again, I can take all my earthquakes and pipe them onto my map. And not surprisingly, we see that the majority of earthquakes happen along where the regions where we know the fault lines are. So again, this is an example of using the type provider, having a very easy way to bring the data into the programming environment and then doing analysis on that data. To conclude the presentation, I'd like to give you yet one more example where we'll see the same idea being applied, but again, we'll be tapping into different data sources, and we'll try to be telling a story which is based on an article which was published on the BBC website, I believe. This is a story in healthcare, and what we'd like to do is compare the cost and the effectiveness of healthcare in different countries. So in order to do that, we're going to need some data. A good place to get data, for example, is the Windows Azure Data Marketplace, which is this place where lots of data sets are available so that people can tap into them. So for example, I can drill into the data section of the Azure Data Market website, and I can see lots of data sets. In our case, because we're going to deal with healthcare, let's drill into the health and wellness category. We see that there are multiple healthcare data sets, and actually if we go to the second page, there's data from the World Health Organization, and this is the data that we're going to be using in our example. And again, as you look at that, you can look at the data as it is described here, and you can start thinking about what if you had to use that data in your favorite programming environment? You know, what type of hoops and work would you have to go through in order to be productive and actually use the data? So let's come back to ThreeBase and let's try to make sense of some of that data. So again, we're going to be using a type provider, a different type this time, one that looks at the Windows Azure Marketplace, the website that we were just looking at. So I need to reference the DLL for the Azure type provider, And the moment I've done that, I can start typing and using IntelliSense to go at the data, if you wish. So I can go to the Windows Azure namespace, there's a marketplace, and if I hit dot again, we can see that I'm offered with an option, all data. And so let's drill into that, see what's in there. And now, as I type dot again, we get all the categories that we were looking at on the web page. You know, whether we want data in the automotive category, banking industry, or eventually health and wellness, which is what we were looking at. And again, I can hit dot again, and I get the different options. And then here there's the World Health Organization data. So this is how I get at the data. Now, in Windows Azure Marketplace, some data sets are freely available. Some require you to register for them. Because the data sets that we're going to be using today require registration, I need to enter my account key, which I'll be doing now. And then I'll again create a data context to access the World Health Organization data. And from that moment on, that data is available to me. So in order to really tell a story, there's still some code that needs to be written, and there's no free lunch. So in that case, let's look at different countries of interest. In our case, the United States, the UK, Singapore, France, and Canada. And let's use the data to figure out what the life expectancy in those different countries is. So we do a query against the live data, manipulate it a little bit, and then type that into a chart to see the result. So let me run that. Again, we're accessing the data from the marketplace on the web, and then creating the graph, which should show up in a second or two. And here we are. So what we see is that for the countries we've selected, the life expectancy is essentially the same. So we could say if, in our scenario, if we say that life expectancy is a reflection of the quality of healthcare, then all those countries have similar expectation in terms of quality. So because we want to compare the quality versus the cost, now let's tap into another data source to try to get information about the effectiveness. To do that, we may again want to tap into World Health Organization data, but this time that data is not available on the Azure Marketplace, but it's available on the World Health Organization website as a comma-separated value file. So again, we can revert to the CSV Type Provider, reference it, and then we can tap into the data and look at how many physicians are in each country per 10,000 inhabitants. And there we see again that, it's fairly similar across countries. Clearly, France here seems to have more physicians, so does the UK. But if we notice the US, which is the last column here, it's very similar to the UK. So what we've seen so far is basically, according to life expectancy, all those countries have similar quality of healthcare. In terms of the effectiveness, how they deliver the care, we can see that it's, again, fairly even, especially between the US and the UK. France is a little bit above, while Canada and Singapore are a little bit below. So now let's look at the cost of healthcare. And to do that, we'll tap yet into another data source. This is the World Bank data. And for that, we have another type provider. So again, I can create a data context, and then I can start drilling into World Bank information. So for example, there's information about countries. For each country, I could drill into information. So for example, we were looking at Canada, and I can keep going into indicators. And then out of that, I can access data for, I think there's about 1,000 indicators. So in our case, the one we'll be using is the indicator called health expenditure per capita. And so for a given country, I can just get the data, draw a chart, and that shows me the health expenditure as a function of time. Now, of course, what we want to do is do it for a list of countries that we've selected, and then plot the cost. So let me expand the graph. Let me actually redraw it with a bigger graph. And so when we look at that, we see that the US, which is given in red here, has a much higher cost than all the other countries. So from that analysis, we could infer that, even though the US provides a similar life expectancy as the other country, and especially compared to the UK, we knew that they had fairly similar number of physicians per 10,000 inhabitants. Then we see that the cost in the UK is much lower than the US. So maybe we could infer that the US is not as effective as the UK to deliver healthcare. Of course, this is just one scenario. It may not be the most realistic scenario, but it actually draws onto real data to tell a story, and this is what data scientists do. So with that, I'm going to end my demo, and I hope that you now have a flavor not only for FSharp, and you know that tryfsharp.org is there for you if you want to try FSharp, because it's not your main language. Hopefully you become interested in it, and you want to download tools on your favorite platform, whether it's Windows or whether it's a Linux environment. And once you start playing with the language, you realize that using a concept like type providers, you have a very powerful way to access data in your programming environment. And now you can use the full power of the language to go from exploration using an interactive environment to building a more interesting library that eventually becomes your production code that you can deploy into your production system. So I hope you enjoyed that demo. And with that, I'm going to end the presentation back to Evelyn, I believe.
All right, so we're going to go now, actually, let's go on the slides, and we're going to have Don, who is going to talk to us about how you can actually use FSharp to program for internet scale, and also, Don, where the community is. The community is in FSharp and try FSharp.
Okay, hi everyone, this is Don Syme. I'm the architect who's worked on the FSharp programming language, and we want to, if you want to dig in more into the research behind the type provider mechanism in FSharp 3.0, I'd encourage you to take a look at the technical reports and papers we've got on programming for internet scale, programming language support for internet scale information sources. Just do a web search for FSharp internet scale programming. Probably the key technical insight in the FSharp type provider work is about the provision of metadata into the programming language in an on-demand way, so that it will scale to internet scale information sources, and FreeBase is a very good example of that, though there are many others emerging on the web. It can scale to give unique types to every individual entity in those 23 million entities in a system like FreeBase. Giving a level of using typing to give a level of fine granularity typing to the individual entities, and that allows for excellent tooling and IntelliSense exploration and strong typing as you work with this web-based data. One of the things that also excites me about the type provider mechanism, as we've seen with Christoph's demonstrations, is the way it integrates data so seamlessly into the programming experience. And to look at that from the student's perspective, as we've been talking about the Computing at Schools project here at Microsoft Research, a very large project in the United Kingdom in which Microsoft Research participates, to me, one of the keys to engaging students with programming is to minimize the time it takes for students to access interesting and realistic data. To see my own children's eyes light up, they're just 7 and 10 years old, when they see that they can access that data from the World Bank. They're very curious about countries around the world at the moment, and to see that they can go and get population statistics or water statistics or food statistics and data from just so simply through the programming experience for the real countries that they want to learn about and be able to chart them in an environment like TriFSharp, data engages the mind. And if you can seamlessly transition from data to programming to visualization, back to programming and back to data, if you can seamlessly switch from data sources such as the World Bank through to data about celebrities through to data about books, and you can do this in a way that scales and works with as many different data sources, then I think that's absolutely one of the keys to engaging the next generation in the wonderful world of programming. And TriFSharp, you can do that directly from the browser now. You don't need to install Visual Studio or some other development environment. You can be up and running in under a minute on TriFSharp.org. So, okay, so the reminder of the URL, TriFSharp.org, to get going. The other thing I'd like to point everyone to is the FSharp community organization called FSharp.org. Now, if Christoph is on the call, perhaps he could do a quick screen share on FSharp.org. That's taking the try off the front of tryfsharp.org. And FSharp.org is the FSharp Software Foundation. Microsoft are very proud contributors to the FSharp community through the FSharp language design and through the visual FSharp tools. We are very excited to be doing an industrial strength language which in particular allows for extremely concise and correct code. FSharp doesn't allow nulls, for example, is one of the only industrial languages which eliminates nulls from routine programming. So Microsoft is very, very excited to be contributing to FSharp through Visual FSharp and the FSharp language design. But we also recognize that we are only one of many contributors to FSharp. And in particular, the FSharp can be used on Linux and it can be used on Mac. We open source the implementation of FSharp, and the FSharp Software Foundation are the group that make sure that open source code will run well on these other platforms. You can also use FSharp to write Android apps and iOS apps through professional tools from a company called Xamarin, who also makes C# available on those platforms. You can also use FSharp and compile it to JavaScript and HTML5 code through two routes, one of which is a professional set of tools called WebSharper, and another is a community recent community project called FunScript. And you can also run FSharp on the GPU, and of course you can also contribute to all of these different activities as well, and have you or your students contribute. And the FSharp community is very active, open source community is very active and very open to having contributions to broaden the use of the language and to allow it to be used for many different purposes as well. Some of the application areas are detailed over on the right: web programming, math and statistics, data access, cloud programming, machine learning, financial computing, and games and apps. So please feel free both to join and contribute to the FSharp Software Foundation, and to have your students also come and join in this great organization. One of the things, final things I'll point you to is the testimonials on the FSharp Software Foundation site. Many people ask, what is FSharp being used for in practice? If you want to know the answer to that, just go over and click on the testimonials tab on the FSharp Software Foundation. You'll find many testimonials. And if you are using FSharp for any purpose, either for hobbyists or for using it in practice in a corporation or for private projects, tell us about that. You can contribute your testimonials just by submitting a pull request to the GitHub site for the FSharp Software Foundation. Okay, I think we're going to take questions now. So I think back over to Evelyn for the Q&A.
Yeah, thank you, Don and Christoph. And now I think so Chris has some questions for us.
Yes, we've had some great questions come in, so thank you, Evelyn. The first one is for Kenji, and the question is, how might I use try FSharp in teaching?
Thanks for the question. Yeah, TriSharp's really useful for teaching, and it's actually the original version of TriSharp was specifically for that. So you can use the tutorials that are on the site in just language, visualization, and data science. So you can pick those up and please go ahead and use those. But also, if you want to create your own content, then if you click on the Create page and log in, you can save your files to the cloud. You can share those on social networks, but importantly, each file has a unique URL. So you can have a link so your students can access that file and use that as a starting point. You use them as code samples in your course. But also, you can embed TriSharp in your own website as an iframe. So you can actually create your own course website and be embedding TriSharp in there so the students can not just see the code, but they can actually click and fire the code, edit the code. So you can partial code snippets up, for instance, that your students have to complete. So there's lots of different ways that you can use TriSharp in your teaching, and do get in touch with us at Microsoft Research as well, because we're very interested to see how people are using TriSharp in teaching, because there are universities around the world that are starting to do that.
Great, thanks, Kenji. Next question, Don, I think you alluded to this on your last slide, but let's re-ask the question anyway. What platforms can I use FSharp on?
Yeah, I mentioned that. I'll also answer the question too down, why FSharp is not open and freely available for all. So I'll first address that those two are related questions. And FSharp is absolutely, it is open source. It's open source under the Apache 2.0 OSI approved license. Microsoft see themselves as just one contributor to FSharp. We concentrate on the Windows platform and on using FSharp on Azure, the Windows Azure, as well as a cloud execution platform. Two very important reasons Microsoft contribute to the FSharp programming language. We're also very concerned about enterprise customers of FSharp, companies, major financial institutions who are using FSharp for modeling and simulation purposes on financial instruments. So that's what Microsoft do with FSharp. We have Xamarin making FSharp, professional FSharp tooling available on for Android and iOS, iPhone and iPad programming. We have IntelliFactory making FSharp tooling available for HTML5 JavaScript programming. We have a company called Earthquake Enterprises doing a set of tooling called Tsunami, which is for FSharp, using FSharp as a scripting language for Excel and design environments like Rhino and AutoCAD. And also FSharp can be used on Mac and Linux systems as well. So FSharp has extraordinarily broad reach for a programming language. It can be used on just about everything, either through the JavaScript route or through the other routes that I've mentioned now. You can find out all about those on fsharp.org. Some of those are professional tooling from a company like Microsoft. Some of the options are done through open source and community routes, but would really encourage people to use FSharp on a broad range of platforms and not to see it as specific to either Microsoft or to the Windows environment. You really can use FSharp on a very broad range of environments indeed.
Great. Thanks, Don, for answering both of those questions. And it looks like we have time for one final question. So, Don, this one goes to you as well. Can you create custom type providers for proprietary data?
Yes, absolutely. The mechanism is absolutely designed to be an extensibility point for the language. If you search around for Create FSharp Type Provider, you'll see tutorials provided by Microsoft on how to create a custom type provider, which you can use in any of the FSharp development environments. People do create very interesting uses of the type provider mechanism, perhaps some of the most unexpected ones. Well, first of all, I'd point you to a project called FSharp.data, which provides a set of high-quality community type providers for document formats, like the CSV provider sample you saw in Try FSharp, but that is now also available in the FSharp data library, but you can also do JSON data and XML data. But perhaps the more surprising one is the R type provider for FSharp, where you can actually use that type provider to interoperate with the R statistical programming environment. And if you have R installed on your machine, and you have FSharp also installed, then the type provider allows you to seamlessly access or near seamlessly access all the R packages that are installed on your system. Up to over 2,000 statistical packages become available through that mechanism. So the type provider mechanism not only allows you to integrate data into the language, but is a general interoperability point for interoperating with other systems. And the community have been talking about type providers for Java code to allow you to access Java and JVM and Scala code from FSharp. There are examples of doing that available on the web. They've also been talking about a Python or a MATLAB provider, so you'll be able to access your Python code from FSharp through the same mechanism. So yes, please go out and create the custom type providers and share them with the community. And again, through fsharp.org and through the discussion email list of the FSharp Software Foundation is a great place to discuss those topics in more detail and get involved with unlocking the world of data and interoperability into this great programming environment.
Excellent. Thank you, Don. And unfortunately, it's the top of the hour. We've run out of time. If we couldn't get to your question, we will respond via email, so look for those questions to be answered. And I'd like to thank Evelyn, Christoph, Don, and Kenji for their very informative and highly interactive presentation today. And a special thanks going to our audience for taking the time to attend and participate. On behalf of Microsoft Research and the IEEE Computer Society, have a great day, everyone.